This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine, online at computer.org/software. Developers, are you ready? It's time to upgrade your data platform to InterSystems Iris. Choose your language. Choose your tools. Choose your environment. Collaborate, build faster, and deploy more efficiently. When you can make faster decisions, there's no telling what you'll create. Ready, set, code. Start coding for free. Visit intersystems.com/try to try Iris.
Hello, this is Justin Beyer for Software Engineering Radio, and today I'm speaking with Torin Sandall. Torin is the co-creator of the Open Policy Agent, OPA, project, and the VP of Open Source at Styra, the company rethinking authorization for cloud-native systems. At Styra, Torin leads development of the OPA project and focuses on helping users and partners succeed. Torin is a frequent speaker on policy and authorization at conferences like KubeCon, OSCon, Velocity, and more. Torin, can you give the audience a quick introduction to what a policy engine is?
Sure. So a policy engine is, you can kind of think of it in layman's terms as kind of like a concierge for your service. So it kind of exists to like offload policy decisions from your software, from your applications, from your API gateways, from your orchestrators, from scripts and CI/CD pipelines to SSH daemons and so on. So a policy engine kind of exists to answer questions for your software when your software needs to make some kind of decision and has a question to ask.
Okay, so essentially it's trying to offload some of the decision making out of your application core and instead allow you to express a decision making process in a separate instance.
Yeah, and it can be, it can be in a library, or it can be in a separate process that runs on the same machine, or it can be in a separate container that's in the same pod, or it can be, in a service that's running across the network. But generally, the idea behind policy engines is they kind of exist to decouple policy enforcement from policy decision making. So the decision making that gets handled by the policy engine based on rules and logic that have been fed into it, and then the enforcement resides inside of the software that queries it. So if you're building like an application that had to serve a REST API, then every time that REST API gets queried, it's going to have to decide whether or not to allow that API request. And so the way that typically would work with the policy engine is that whenever the API request comes in, the application would query the policy engine and say, should this API request be allowed? And the policy engine will do a bunch of crunching and figure out, essentially yes or no, whether that should happen. And it'll hand that answer back to the service or to the application so that it can be enforced.
Okay, so essentially it'll make a Boolean logic decision and return that to the application. And just to table it, we will definitely go back and talk a little bit more about the implementation of a policy engine in an application, but I just want to change direction a little bit and start specifically talking about the project you're involved in, Open Policy Agent. So what is it? How does it fit into this domain of policy engines?
Sure. So the Open Policy Agent, or OPA, as we like to call it. Some people call it OPA. We call it OPA. People can call it whatever they want. We like to call it OPA. We started the project a while ago, about 4 years ago in early 2016. And what OPA kind of provides is basically a building block for enforcing policies consistently across a wide range of software. So at its core, it provides a way to express policy and then an engine to evaluate policies and produce decisions that can then be handed back to your software to be enforced.
Okay, that makes sense. So how specifically does OPA work?
So the way that OPA works is that you express your policies in a high-level declarative language that's kind of purpose-built for expressing policies and rules. And then you feed those rules into OPA via well-defined APIs or off of the file system or however you want. And then whenever your software needs to make a decision or needs to obtain a decision, it can query OPA and it can ask, give me back the decision for these inputs. So for example, if you were building a microservice and that service exposed an API to serve, financial reports or something like that, or salary information, then whenever a request comes into your service to look up the salary of an employee or to look up some financial report, the service would decide to query would need to make a decision about that, and it would query OPA. And inside of that query, it would describe the request that was happening to itself, right? So it would provide things like the method and the URL and the HTTP headers and maybe even the message body and all this data and it would give that over to OPA. And it would be asking basically for a decision, a yes or no, like a Boolean answer, like true or false. And so then OPA would evaluate the rules that had been fed to it previously, and it would the outcome of that evaluation process would be the decision. It would be true or false or allow, deny, or whatever you want to say, and that would be sent back to your service to be enforced.
Okay. So essentially, I take a policy, I write it in this high level language, and then I put it into OPA through whatever method it be. And then my application then uses OPA to say, based on this information that I received, should I allow this request or deny this request?
Exactly. So there's kind of like two sides to it. There's you as a policy author and somebody who's responsible for kind of managing policy in the system, right? So you're responsible for writing down the rules that govern who can do what, and maybe you're also responsible for building out some of the systems that distribute those rules. And then there's the software that actually needs to get decisions when things are happening, when API requests are coming in, when users are trying to SSH into machines, when scripts are running inside of CI/CD pipelines. That software is solely concerned with the decision, like getting back a decision from OPA. And so it'll ask OPA for policy decisions when it needs them.
Okay. And how do you express this policy? What's the language for it?
So the language for expressing policy with OPA is called Rego, and Rego it's a Latin word. It means to rule. So we thought that was a good name for a policy language. It turned out that we didn't have any Australians on the core team, and it turned out that Rego actually means, or Rejo as it's pronounced, means car registration in Australia. So we learned that a little bit too late to kind of rename it. But so anyway, you write your rules in Rego. And what they basically exist to do is answer questions, right? Because your software's got to make these decisions, and those decisions are often formed in terms of questions, right? Like, is Alice allowed to see Bob's salary or something like that, right? Is this workload allowed to be deployed, or maybe more interesting, like what policies could be violated if this workload were to be deployed, or what records should someone be allowed to see, right? These are all kind of questions that are like policy in nature. And so the language that OPA gives you is a high-level declarative language that lets you write down rules that govern those kinds of decisions. And so the language is very good at expressing kind of logical statements over arbitrary sets of data.
Okay. So it's essentially implementing attribute-based authentication or authorization to that extent. So it's saying, here's this attribute, and my policy is that Jane can see financial data, but she can't see personnel records. So I would write that in Rego and say, users with this attribute of financial manager can see financial records, but can't see personnel records.
Yeah, exactly. There's typically like a phase before authorization, which is authentication, that happens, before you actually decide whether or not to allow or deny some kind of request. And so that authentication phase is super important. But once that finishes, like once you've kind of decided or verified that Alice is who she says she is, then you need to make this decision. And that decision making process comes down to logic, and it comes down to attributes that describe who Alice is, what action she's trying to perform, what resource she's trying to access, as well as the environment that all the software is running in, right? It might depend on what device Alice is connecting from. It might depend on how she authenticated. Did she go through multi-factor or not? It might depend on, the time of day and so on, right? There's all kinds of different environmental factors that affect the decision-making process. And so with OPA and Rego, what we try to do is give people a language that's very good at expressing logic over all these kinds of attributes.
Okay, so I would authenticate the user and, let's say, give them back an OAuth token with the attributes about how they authenticated, whether they used multi-factor. And then when they come back to the application, provide that token to prove they are who they say they are. That's where OPA fits in and starts to apply the policies almost. And we will touch on this a little bit later, in that zero trust networking kind of way.
Yeah, exactly. So typically the way that we think about identity and token, like OAuth tokens or JSON web tokens, is that they are just another kind of set of attributes that inform the decision making process. There's nothing inherently special about they're obviously super fundamental to the policy, but there are lots of other things that are important. So they're just another source of data or context that informs the decision making process. So that's kind of how it works at a high level. When you actually start writing Rego, what you're essentially doing is putting down just a bunch of if-then statements. You say, you are allowed to perform this operation under these conditions, and you kind of just write down the conditions under which things are allowed to happen or not allowed to happen, or potentially how the incoming request might need to be modified or changed, or obligations that might fall on the client, and so on.
Okay, so changing direction a little bit here. Let's talk about how it's actually implemented. So I take OPA and I have my application that exists. What kinds of applications benefit from me putting OPA in it? Are we talking, small applications, huge enterprise applications, large distributed systems? Where does that benefit start to show with OPA?
So we made a very conscious decision early on in the project to try to keep it as kind of flexible and domain agnostic and general purpose as possible. And so I personally think that applications, big and small, in different kinds of domains, can actually benefit quite a bit from it. Where we see a lot of interest today for the project is from companies, enterprises, large organizations that operate in highly regulated environments like financial services companies, healthcare companies, and so on. And we see kind of like two broad categories of use cases. So one use case is mostly around configuration validation, essentially. This is what people are typically talking about when they talk about OPA in the context of Kubernetes. In that context, OPA kind of exists to put safeguards or guardrails in place that protect the clusters, the Kubernetes clusters, as well as the applications that are running on top of those clusters from themselves and from each other, and so on. So that's kind of like one broad category of use cases, just kind of safeguarding platform configuration and the metadata that defines compute, network, and storage resources in the sort of cloud native stack. The second kind of major category of use case or kind of application for OPA is just this kind of API authorization problem, right? Every single time you build a microservice or some sort of application, you have to build out AAA, right? Authentication, authorization, and accounting. And so there are kind of industry standard ways of doing authentication, but authorization, on the other hand, is typically been deeply kind of embedded into the business logic. And what we're seeing now is that people are kind of realizing that it's better to decouple that and split it out and offload it to a component like OPA. So there are all kinds of API authorization use cases around microservices as well as applications, whether you're talking about implementing role-based access control or attribute-based access control, or you want to implement an AWS IAM style access control model. There are various companies that are using OPA just exactly for that.
Okay, so one of the huge benefits is almost I can have a consistent authorization across my entire stack. So if I put up a Kubernetes cluster and launch my new application and I'm already using OPA as the basis of authorization for my existing 400 applications, I can then take those same roles and apply specific controls within that application, but still map to those same roles.
Yeah, there's nothing kind of that would inhibit you from using contextual information that describes like the running software when you're writing policy for Kubernetes clusters or writing policy for your services, and having the ability to express policy in a kind of a uniform and consistent way across a wide range of software, whether you're talking about microservices or platform services or even host level daemons like SSH is tremendously valuable when you're talking about these large organizations that otherwise have very poor kind of control and visibility over the rules and the governance of the system.
Exactly. So there's definitely some compliance benefits that you could get out of it, which I'm going to circle back a little bit later to talk on some of those benefits. But just to dive a little bit deeper into the OPA client and how that would be implemented, how does it handle a lot of the issues we see with like distributed systems where, we can't get 100% network reliability, or you might end up with a split brain problem or something to that effect?
Sure, that's a good question. So when it actually comes to using OPA, to integrating it into your stack or into your software, you have a couple different options, and we kind of tend to think of OPA as this essentially like this host local cache for policy decision making. So you can either embed it as a library if you're building services in Go, or you can actually just run it as a daemon, as a standalone server. But in either case, well, I mean, in both cases, we recommend that you run it essentially as close to your software as possible, right? So if it's embedded as a library, it's in the same process. But if it's running as a daemon, we recommend that you take it and you run it as a host level daemon, essentially next to your software, or in the case of Kubernetes, as a sidecar container. That's sort of an architectural pattern within Kubernetes. And the reason that we recommend that you do that is sort of twofold, right? So if you imagine like an application that's kind of designed with a service oriented or microservice architecture, when an incoming request hits that application, it might have to traverse 4 or 5 or 10 or a dozen or 20 or something microservices in order for it to be fulfilled. And if at every single hop along the way, your services or your software has to call out across the network to get a policy decision back, then there are a few different things that can go wrong. And I think you kind of alluded to them there a little bit with things like split brain, right? So one thing that can happen is that the network can get slow, or it's certainly going to introduce latency into the path, right? And so if every hop you have to pay this network overhead, then that's going to impact your overall application latency, right? And so your application is not going to perform as well, and your users are going to be unhappy. The other impact is that it's going to affect your application's uptime. It's going to affect its availability, because if at every single hop along the way you have to call it across the network, then if there's a network partition or the host that OPA is running on crashes, it dies, then your application is not going to be able to get a decision back, right? The service is going to ask OPA for a decision, and it's just going to sit there waiting until some timeout expires, and then it's going to fail. It's going to encounter an error, and it's going to have to make a decision, I guess, basically at that point about what to do. Because authorization is kind of this fundamental security problem, because it exists in the critical path of your application. You typically have to fail closed. So that's going to impact your availability. It's going to impact your uptime. And so because of that, because of performance and availability, we recommend that you take OPA and you run it as close to your software as possible, ideally on the same machine.
Okay, so it's the classic balancing security and the confidentiality, integrity, and availability. Balancing those all out, and by putting it as close as possible to the service, we're still getting the availability that we probably need for our service, but still ensuring we get the required security controls in place for our application, especially if it's something in a highly regulated industry where the expectation is every request should be authorized to some extent before it's allowed.
Yeah. Now, of course, OPA is very flexible. You can embed it as a library. You can stand it up as a daemon. If you want to run it across the network, if you want to run it as a service, we don't stop you. You can do that, but it is kind of on you to think about the availability and performance impact that's going to incur on your application. So, we don't force you to run it on every machine or next to every application, but that's kind of that's how we thought about OPA at the beginning, was that it would enable a distributed enforcement model for policy and authorization, right? It didn't. A lot of legacy systems are kind of overly centralized. They were designed for like older environments, and so that's one of the things that OPA does a little bit differently.
Okay, and that definitely is helpful to know that it's able to handle this distributed systems issue. But just a little bit more on that, as we're talking about putting OPA as almost a sidecar to every application, or as close as possible to the application, how do I manage all of these OPA agents and provide a consistent policy across all of them?
Right. Yeah. So if you have like all of these agents that are there, and by the way, OPA keeps all of the rules and data that it uses to make decisions in memory. So it doesn't have any kind of like decision time dependencies on any kind of external database or anything like that, right? So all the evaluation happens locally inside of the agent. There are mechanisms to call out from inside of the policy if you need to, but by default it doesn't do that, right? And if you architect your policies the way that we kind of encourage, then it won't. But so if you have your kind of architecture set up, so you've got these agents running throughout your infrastructure, and they're all storing everything in memory, you need some way to manage them, right? You need some way to kind of control what policies and rules they have loaded, and you want to know what decisions they're making at the end of the day, right? That's important for audit and accounting. And so what OPA does to enable that is it exposes a set of management APIs. So those APIs are basically, they just exist to provide control and visibility over the agents. So OPA has an API called the bundle API, which you can use to essentially distribute bundles of policy and data out to the agents. Essentially, you configure OPA to periodically phone home to a remote HTTP server, and OPA will kind of sit there trying to get the latest version of policy, and it'll periodically download it and activate it. And so that can be a simple HTTP server, serving off of a file system. You can point OPA at S3. You can write, your own service to serve policy and data, and we see people doing all kinds of stuff like that. OPA also has other APIs for visibility. So it's got what we call a status API for receiving notifications about basically like what version of policy OPA is currently running and whether there are any issues activating the last version that it got from your bundle API. And then there's also the decision log API, so that you can configure OPA to keep a little record in memory every time it makes a decision. So every time your software queries OPA, it'll keep a record of that around. And that record includes all of the input attributes and the decision that was made, as well as a pointer to the version of the policy that it had loaded when it made the decision. And then it'll periodically flush those out. It'll upload those to a remote API, or it'll send them to a logger. And so then you can kind of aggregate those decisions and do all kinds of analysis on them. So OPA has these kind of like primitive APIs that architects and developers can kind of build on top of if they want. And then of course, there are companies like Styra that provide a commercial control plane for managing open policy agent deployments.
Okay, so the policy agent itself is almost a data plane level agent providing the authorization for a service, and then you would still want a control plane to provide the policy, gather feedback from the agent, check statuses, verify it's running the latest policy, so that you can detect issues like an agent running one version of policy, and then you push out a critical change because you notice an issue with it. That way you can detect, oh, well, these agents over here in this application aren't being updated. Why?
Exactly. Yeah. Having like a visibility and understanding the performance and state, of the OPAs is super important. And then also having a kind of a record of the decisions that the agents have been making is also super valuable from an audit perspective, because now you can kind of build up this historical record of all the decisions that have been made over time, across your stack effectively. And so that's powerful for audit. It kind of feeds back into rollout and distribution of policy, because you can use that historical record to do things like back testing and so on policy changes before you go and roll them out.
Calling all developers. There's no telling what you can create when you upgrade your data platform to InterSystems Iris. Are you ready to build the applications you want, however you want them? Are you ready to develop applications faster than ever? Collaborate, build faster, and deploy more efficiently. Tomorrow's next breakthroughs are waiting for you today. InterSystems Iris Data Platform. Ready, set, code. Start coding for free. Visit intersystems.com/try to try Iris.
So, Torin, when we're talking about using OPA, let's just focus in a little bit more on the security aspects of it. Where would we put OPA into the application security stack? I know we're using it for authorization, and I know it's next to it, your application that you're running, but what's the advantage of using OPA over, I think, very traditionally, like an LDAP query based on a security group, or just trying to take OAuth claims and enforce that in the application?
Sure. So whenever you're trying to secure an application, the first thing you have to kind of figure out is how you're going to do identity and authentication, how you're going to verify, that I am who I say I am when I'm connecting to the system. And that's what things like OAuth kind of help you do, right? So OAuth, the way that I think about OAuth is that it's sort of like power of attorney for software, for applications, right? It allows me to grant some piece of software the ability to do something on my behalf, right? But what OAuth doesn't define, what it doesn't solve for you, is once that kind of grant has been made, that grant still has to be validated by the server that's receiving the request from the application, right? And so today and in the past, what had happened is that the validation of those grants, those claims, would just be deeply embedded, hard-coded into the application business logic. And that's for good reason, because OAuth, if you go read the OAuth RFC, it doesn't tell you, this is how the claims need to be validated. It might say for some of them what to do, but for others it says this is outside the scope, right? It's just not part of OAuth. So the decision making around validation of claims and stuff is an authorization problem, and it's a policy problem at the end of the day. So that's kind of where OPA comes in. What OPA allows you to do is have that basic kind of claim validation just simply offloaded from the application, from the service, to a dedicated engine that allows you to express it uniformly, consistently across a wide range of software. And so this is particularly valuable if you're talking about, a large organization that's trying to roll out, OAuth or, some sort of authentication practice like multi-factor across a wide range of applications. Because instead of having to go into each and every application and, reconfigure it or make changes to the implementation of that application so that it supports multi-factor, they can just do that in one place. They can go into the policy and they can say, okay, now require multi-factor for, users that are connecting from, certain geographic regions, or users that are connecting to the system outside of business hours or something like that, right? It makes it much, much easier to roll out these kind of like enterprise or organization-wide security policies to fleets of applications.
Okay, that makes sense. So it gives you that generic container where you can tell the generic container of OAuth, hey, based on these claims, this is how I interpret these. And then within the application, be able to query that consistently and say, I got these claims, what do I do? Or is this action acceptable?
Exactly. And there are different ways you can do that integration. It can happen inside of the application itself. The application can query OPA and say, is this token valid? But it can also happen elsewhere. It could happen inside of the kind of app or web framework that the application's implemented inside of, right? So take like a Spring, framework, for example, right? You can just have a simple Spring security plugin that knows how to query OPA whenever an incoming request comes in. You can also do it outside of the application with a service proxy like Envoy, right? So that's another way of integrating, is to just have, or rather inserting policy enforcement into your stack, is to take a proxy like Envoy, put it in front of your application, and then configure Envoy to talk to OPA and ask for example, OAuth tokens to be validated as requests come into the system.
Okay, so it still is able to pull that, authorization out of the application, and it's really just focused on doing that within OPA. Now, changing gears just a little bit here, we did do an episode on zero trust networking, episode 385, and I'll refer viewers back to that for more information on that field specifically if they're not familiar. But where does OPA fit into that whole architecture of zero trust networking?
So zero trust is kind of about removing assumptions around security from the system, right? So if you look at legacies or like older systems, what they rely on is kind of centralized perimeter-based network security, right? So it's kind of like if you have a house and you put a lock on the front door, right? That's kind of like perimeter-based security, right? Inside of the house, there's no locks. You can go into any room at any time, and it's kind of free for all. With zero trust, you're basically going into the house and putting locks on every single door. Now that could be a little bit kind of creepy, I guess, but but the idea is kind of sound, right? And so the challenge there, I think, a lot of the time is around usability, right? How do you kind of maintain usability, and how do you kind of make security something that doesn't just totally get in people's way, because otherwise they'll find ways to bypass it and get around it. But OPA is kind of like this engine that you can use to put locks on every single door in your house. It's intended to be super lightweight and super easy to embed. So it does fit very nicely into these kind of like zero trust architectures.
And with OPA, can we leverage, I know you mentioned enriching the data, but can we do a more like complex authorization workflow, like saying, if I logged in and wanted to do this action, now I can log into the application without multi-factor, but now that I want to do an admin action, I need to do multi-factor.
Yeah, that's a good question. And I think earlier on when we were talking, we were focusing on policies that generate kind of Boolean like decisions, right? Like yes, no. But one of the things that kind of separates OPA from a lot of other projects in the past is that it actually allows you to generate non-Boolean decisions. The decisions that you generate from your OPA policies can actually be arbitrary JSON documents, JSON objects or values. And so what that means is that if you want to generate a decision that says, well, maybe you're allowed, or no, you're not allowed, but if you go off and you go to this URL and you authenticate and you come back, then you'll be allowed access. That's something you can actually express today quite easily inside of OPA.
Okay, so I can provide a more complex workflow and say, oh, well, now that you want to do this, you have to go here, or give back the application more information other than just a yes allow or no don't allow. I can say, well, I'm not sure, they need to go here, and then come back and ask me again.
Exactly. So we see this a lot with our Envoy integration. People will write policies that return the actual HTTP headers that force a redirect of clients coming into the system, right? So it just builds on top of standard HTTP redirection.
And then can you give me a specific example of an application where you've implemented OPA and it improved the security of the application overall?
Sure. I mean, there are tons of companies that have talked publicly about how they're using OPA at scale. Recently, we held our first ever OPA summit back in San Diego at KubeCon in November, and at that event, we had a bunch of different companies from kind of different verticals come and talk about how they're using OPA. And one of the coolest ones was how Pinterest is actually leveraging OPA to enforce all kinds of different policies across their systems. So they're using OPA for standard stuff like config validation inside of CI/CD pipelines, and then they also talked about how they're using it for API authorization and microservices. But then they're also going even further, and they're using it to control access to Kafka, right? And so Kafka is kind of like this data. It is the data plane, right, for a lot of organizations. It has just a huge amount of information flowing through it on a daily basis, right? And so they shared how they actually use OPA at scale to enforce authorization or access control over who can basically connect to certain Kafka topics and produce or read from them. And the numbers that they shared were pretty impressive. It was like at peak, it was serving about, across their Kafka fleet, it was serving something like 500,000 authorization queries per second globally across all of their clusters. And then when they added caching on top of that, it went up to something like 8.5 million. So the numbers that they shared there were pretty cool. And it was just neat to see that kind of publication of how people are using OPA kind of at scale to solve real security issues. Another example that came out from KubeCon was some folks from Goldman Sachs that run Kubernetes showed how they use OPA to not only define admission control policies to safeguard the cluster, to say things like, you're not allowed to run privileged containers, or you're not allowed to run images off the public internet, but they also use OPA to define desired state or configuration for Kubernetes. So like whenever a namespace gets created, right, and this happens all the time for new teams within Kubernetes, policies are in place to automatically so that what happens is that automatically security resources get provisioned. So things like RBAC roles, things like quota, as well as other things like persistent volumes and other objects. So there are tons of different use cases, and I recommend that people go online and kind of look around on YouTube and other places for examples of how people are running OPA in the wild.
Okay, so essentially OPA has this huge range of resources, and we can use it for things like authorization, or we can go all the way over almost on the other side and say we're doing config validation, and we're almost forcing baseline templates whenever you do any type of specific action.
That's right. Yeah. And that's kind of been the goal since the very beginning, was to provide a kind of a unified or a consistent way to do that across a range of software. So it's been super satisfying to see people actually kind of get to that point today.
So just changing gears a little bit here, I want to move over to the compliance and audit side of it. How does using OPA help with that? Does it help reduce how much work we have to do when we're doing an audit of an environment to verify that, appropriate access control is being implemented?
I talked to someone a while ago from a particular company, and they told me about how they tried to embark on this exercise to determine whether or not a public API request, like a public request coming in from the internet, could access credit card data basically in their system. And this was like a large scale application consisting of many microservices or different kind of layers of services. And they basically determined that it was going to be impossible to answer that because of the fact that the authorization decision making was basically hard coded in n different places, and there was no way they were going to be able to in an automated manner or even in a manual manner go through and kind of audit and figure out for every different application or service whether that was whether public traffic could reach credit card data. And so the value there for them for using something like OPA is that you no longer have to go into each and every service, right? You no longer have to go into each and every application and look at each and every implementation of policy and authorization, right? If you're a security engineer or a compliance officer or something like that in a large organization, there's no way you're going to be able to ramp up on all of the different programming languages and frameworks and implementation patterns that all these different applications and services are implemented with, right? And so just having that one unified way of expressing policy across a wide range of services, just by having that kind of allows you to decouple the decision making from the application business logic and have it represented in one way. That's tremendously valuable. If you talk to people that do audits and so on from large organizations and highly regulated industries, they'll tell you the horror stories about spending weeks and weeks and weeks inside of meeting rooms trying to do these audits. And it's very difficult because there's so many different ways of specifying who can do what, and that's what we're trying to solve.
Exactly. So because everybody's implementation is a little bit different and every language is a little bit different, the way I might implement authorization in one service isn't necessarily the way I would implement it in another. And I might have 500 different patterns in one service, 400 in another, 200 in this one over here. And there's no way you're ever going to be able to trace down all of those paths individually to say, well, the request that hits this service, then this service, and this service will never be able to get here unless it has this attribute. Whereas with OPA, I can say, oh, here's this general policy. Does it meet these requirements? And does the application implement OPA correctly? And if it does, then I can assume that it will be enforced correctly.
Exactly.
Makes sense. So just going a little bit more into the compliance side, is there any benefit on the like data governance side of the stack? So when we're talking about config validation, is there a way for me to say my US customer data won't ever get started in the Kubernetes cluster we have in Europe?
We do have some users that are using OPA today for putting access control basically in place over self-service provisioning platforms, right? So, a lot of organizations are trying to move towards more kind of like self-service platforms for provisioning things like message brokers and databases along with applications. And that's great because it kind of increases velocity for developers and applications in the organization. But at the same time, you need to be careful, right? You don't want to accidentally have someone's data from the EU getting shipped off somewhere else, right? And so putting kind of governance or guardrails in place over self-service provisioning platforms is something that we see people using OPA for today. We also see people using OPA to implement access control with different data lake kind of projects, right? So Kafka is one example. We've also got integrations with things like Ceph and MinIO to implement similar types of fine-grained authorization policies that say, you're only allowed to connect to, or you're only allowed to access this bucket or these objects, if you're connecting from the right geographic region at a certain point in time, and so on. So the authorization problem there is quite similar. There are some more kind of speculative integrations with OPA that try to go even further into the data authorization problem and control access to data at a very fine-grained level, so like at the row level or at the column level inside of a database. And you can do that today, but it's definitely more of a cutting-edge use case.
Okay, so more of the cutting edge use case, I could put in OPA and say, my column of credit card numbers is inaccessible unless you have the appropriate role to access a full credit card number. And I'm doing that because I need it for PCI compliance. And now I can say with OPA, yes, here's my policy that says that only these people can access full primary account number. Therefore, I'm PCI compliant because I'm limiting access to it.
Yeah, and I mean it can go even further than that too. And you might want to say, for example, that a customer, like, so suppose you're a large financial firm and you've got customer service agents. You might not ever want them to see like a social security number, for example, right? But you want to allow people obviously to see the last four digits of their own social security numbers. And then there are certain people in the organization, like somebody from like risk or something like that, that needs to be able to see the full social security number, right? And so the decision about like how many digits to mask out on a social security number is another example of a policy decision, and that's an actual use case that some folks have for OPA today.
Okay, so instead of trying to implement that in my application and then having 6 applications that access the same database all mask it a little bit differently, I have one system that's saying if they're a customer service agent, they get no unmasked digits. If they're in fraud, they get the last 4. If they're a customer, they get the last 4. And if you're in finance, you get the whole thing.
Exactly. Yeah.
Awesome. So that gives me that ability then to almost make that attestation and very cleanly provide one single sheet of paper to my auditor and say, here's who has access to this because these are the roles that they have and this is the policy we enforce.
Exactly. Yeah.
Awesome. And then is there anything that I missed that you think a software engineer should know?
No, I think this was super fun. The project is growing quite a bit. We've got KubeCon Europe event happening in at the end of March, the CNCF Linux Foundation event happening at the end of March, and lots of people are going to be there talking about Open Policy Agent. So if you're in Europe at that time, definitely check it out. We love contributions back to the Open Policy Agent. So if you are using it and you have an idea, or you see a bug and you want to see it fixed, please come and engage with us. And we also love new integrations. So if you have ideas for integrations for the project with new pieces of software, please come and share that with us. One of the things we launched recently was an ecosystem or integration index on the website. So if you go to the website now, you can see a nice list of all the different integrations that we know about, and you can submit a PR, and your integration will get added to that page. So do check that out.
That's awesome. I'll definitely make sure to include that link in the show notes. And then just one other thing before we finish up. I noticed a project that seems similar to Open Policy Agent, the Gatekeeper project. What is that?
So Gatekeeper is part of Open Policy Agent. What Gatekeeper is sort of like an evolution of something that people had been using OPA for a long time inside of Kubernetes, this problem of admission control. What we've done is we've taken OPA and we've kind of provided some first-class integration with Kubernetes. So that project is being developed jointly by Styra, Microsoft, Google, and others. And the kind of mission there is to provide a first-class, Kubernetes native way of managing admission control policy. So it gives you some nice features on top of OPA, like audit, for example, the ability to audit your cluster against your OPA policies. And then it also introduces a kind of a way of parameterizing or templatizing your OPA policies so that you can have kind of packs or predefined sets of libraries of policies that you can then easily install on your cluster and then configure and be off and running. So that's a super cool project. It represents the work of a lot of people.
That's awesome. And then what's the future direction you see with OPA? Any major changes on the horizon?
The project itself is pretty stable. We're probably going to declare like a 1.0 release pretty soon. We take things like backwards compatibility very seriously, and I think that OPA is doing a pretty good job with its kind of like core objective of enabling people to do config validation and API authorization. But there are some kind of new use cases that are more like speculative, like data filtering that I mentioned a minute ago, and data masking that we're trying to improve, that we're kind of working on improved support for. And then we're also, one of the things we announced late last year was kind of basic G8 support for taking your OPA policies and compiling them into WebAssembly using OPA. And so that ability to target WebAssembly runtimes, whether they're in a CDN or they're in a service proxy or they're in a database or they're in your browser, is something that's going to be super powerful and is going to become more and more prevalent, I think. So that's sort of on the cutting edge of OPA development right now.
Well, that'll be a fantastic product to see coming out of OPA. So, Torin, I just wanted to thank you for coming on the show and discussing how we can leverage policy engines like Open Policy Agent for software security. This is Justin Beyer for Software Engineering Radio. Thank you for listening.
Developers, take your marks. It's time to upgrade your data platform to InterSystems Iris. It's time to deliver complex mission-critical applications in the fastest route possible. It's time to use any data from any source. It's time to embed analytics and create interactive user interfaces. So what are you waiting for? Choose your language, choose your tools, choose your environment. Collaborate, build faster, and deploy more efficiently. Done and done. Tomorrow's next breakthroughs are waiting for you today. InterSystems Iris Data Platform, the fastest way to build applications. Ready, set, code. Start coding for free. Visit intersystems.com/try to try Iris. Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.